Okay, so in this video we're going to discuss the 1120 tutorial sheet 3, and if you still have challenges with tutorial sheet 2, the video is already uploaded, so you can scroll through the channel and check through for tutorial sheet 2 solutions. Okay, so now our first question here says, given that the equation p of x is a quadratic function where x represents the number of items sold, describes the profit function for a certain business, how many items should be sold to maximize the profit? So now this is a quadratic. The only thing we have to do is to complete the square, and when we do so this is question 1. So the first thing that we do is complete the square, and if we were to complete the square here, we'll say this is going to be a negative 2, then this will be x squared, this will be minus a 90x, then this is going to be a positive 500, and we can introduce x here. We can do the reverse difference of two squares, how we complete the square. This is going to be half of 90, which is just a 45, then squared minus negative 45 squared. This is plus a 500. Then the negative 2 is waiting outside. Then this will be x minus 45 squared. Then this will be minus. Then this will give us a 225. So a 2025. Then plus a 500 this side. And this will be negative 2. This will be x minus a 45 squared. Then this minus a 500. This is going to be a negative 1525. And if we multiply back by 2, so this is going to be negative 2 x minus 45 squared. This is plus. This is what you get. So the turning point is just a 45, 3050. So I'll say x is equal to 45 items. This is the number of items that need to be sold when you solve the inside part, and the maximum profit that can be made is simply the y component, which is simply the 3. This is, if it was in kwacha, I would say 3050 kwacha. So this is what you get. So this is what you needed to do on question number 1. If the method that I have used is a bit complex, or you find it hard, you can just use the formula to complete the square. So the formula is always going to give us the same result, which is just your 4ac then minus b squared, then 4a, because here your a is negative 2, your b is 180, and your c is simply a negative 1000. So that's what you have for the first question. Then your second question is simply about roots. So here you need to remember that your alpha plus beta is equal to negative b over a, and your alpha times beta is the same as c over a. This is c over a. Then you know to say, to get back any quadratic that you want, you will always just have x squared minus alpha plus beta, x then plus your alpha times beta is equal to 0. So these are the formulas, plus many more, right? Yeah, so there's a separate video that explains the alpha and beta examples or illustrations. So here they're saying a quadratic has been given. This is our quadratic, and they want us to find the value of each of these expressions that have been given here. So we'll go through each and every question. So we'll start with the first one. So the question wants us to get alpha over beta plus beta over alpha. You need to write this at the beginning to say alpha plus beta is the same as negative c and negative b over a. So negative, your b is negative 4, your a is 1. This is just 4. So alpha plus beta is that. and alpha times beta, you know it's C over A. This must simply give you a -2. So when you are given something like this, you simply write the common denominator of alpha times beta. Then this is going to be alpha squared, then plus your beta squared. Because beta into alpha beta is simply alpha. Alpha times alpha, that's the alpha squared. Then here you simply get your beta squared. Then the guy on top, please remember that alpha squared and beta squared is the same as alpha. So let me show you how we derive this. So if I give you alpha plus beta and then square it, this is the same as alpha squared plus 2 alpha beta plus beta squared, meaning alpha plus beta squared minus 2 alpha beta is the same as alpha squared and beta squared. The reason why we're doing this is because there is no direct substitution that can give us alpha squared and beta squared. The only things that we know is alpha plus beta and alpha times beta. So no wonder we're always going to be looking for expressions that will put into the form alpha plus beta and alpha times beta. So the top part is the same as alpha plus your beta, then squared, then minus 2 alpha beta. The bottom part is already okay, it's alpha times beta, which we do know because alpha plus beta is a 4, so we know to say this is just going to be a 4 squared minus 2. Alpha times beta is just -2. Down as well, you're having a -2. So there's a -2. This will now become 16, then plus 4 over a -2. This will just be a 20 over a -2. This is leaving us with a -10. So that will be the answer for the first part. Alpha over beta plus beta over alpha is just giving you what? A -10. Yeah, so same applies to the next question, our B, this guy here. So they're looking for alpha cubed. So we have the second one, we have alpha cubed, then plus beta cubed. So we need to first of all expand. So we expand. So you look at the power that has been given. The biggest power here, the power given is 3, right? So meaning I'll just expand alpha plus beta to the power 3. This will give us, if you do this by itself 3 times, you'll find this. This is what you're going to get. Plus 3 alpha, then beta squared, then plus beta cubed. You are seeing alpha cubed and beta cubed, right? So we take everything else, this part, on the other side. So this is going to be alpha plus beta to the power 3 minus 3 alpha squared beta minus 3 alpha beta squared. This is equal to alpha cubed, then plus beta cubed. So this will just be alpha plus beta to the power 3 minus 3 alpha beta. Then you have alpha plus beta. That's what remains. So this is simply alpha to the power 3 and beta to the power 3. So here now we can make our substitutions because we know what alpha plus beta is. Then we know what alpha times beta is. That's -2. Then we have a 4 there. This is a 4 to the power 3. So 4 by 4 by another 4. That's going to be a 64. This is a plus. This is going to give us a 6. That's going to give us a 24. So this is going to give us an 88, if I'm not mistaken. So I hope this is okay. Okay, so we can go on to the next one. The next one is simply number C. So question 2C, they want us to get alpha. Alpha minus beta cubed. Alpha minus beta, squared. That's our question, right? This is what we're having. So now, if we want to get this we'll just expand it. This is going to be alpha squared, then minus 2 alpha beta. Then this is the same as plus beta squared. Now, alpha squared and beta squared, that's alpha beta. We've already gotten what this is because this is what we're from calculating. We got something like this. We said this top part here, when we deal with alpha squared plus beta squared, we got it to be what? To be a 20. So we'll just replace it here. So this is going to be, because it's the same questions too, that's 20. Then alpha times beta is simply -2. So this will just give us a 20 plus a 4. That is going to give us a 24. So this is what we have. Then the next question is asking us for 1 over alpha squared plus 1, and then you have plus 1 over beta squared plus 1. So this again, in a similar way, we can first of all compose them to get one thing. This is what we are having. Then 1 over, you have beta squared and plus 1 over alpha squared plus 1. Then you have beta squared plus 1. This will be beta squared plus 1, alpha squared plus 1. This will now change, and you're going to have alpha squared plus beta squared, then plus a 2 on top. Because you gather the like terms, then the down part we can just multiply alpha squared and beta squared, then plus alpha squared, then you're going to have beta squared, then plus 1. So we know what alpha squared plus beta squared is, so this I can just rewrite this. You know it's a 20, then plus 2. Down where you have alpha squared and beta squared multiplying, it's the same as alpha times beta squared, right? So this is the same as -2 squared. This is just a 4. So here I'll just put a 4 plus this, you know it's a 20, then plus a 1. So this is going to be 22 over a 25. So that's what you get as your answer. Yeah, so provided you did get the right alpha plus beta and alpha times beta, everything else must be falling in place, because these two things are the most important ones that we need. Yeah, so this is basically what we need to answer any question. So same applies to your number E, this one here. They're just testing your skills of manipulating these things. So they've given us 1 over 2 alpha plus beta. So number E, 1 over 2 alpha plus beta. Then there is a 1 over alpha plus 2 beta. So now here we're going to get 2 alpha plus beta, and then we have alpha plus 2 beta. Then we can have our alpha plus 2 beta plus your 2 alpha plus beta. This is just going to give us your 3 alpha plus your 3 beta. Then down you just get your 2 alpha squared. When you multiply, then you get your 4 alpha beta, then you get your alpha beta, then you get your 4, your 2 beta, because we're multiplying, we are multiplying the first thing. So we multiply 2 alpha with alpha, that's this. Then you're multiplying 2 alpha with 2 beta, that's this part here. Then now we're multiplying beta times alpha, that's the alpha beta here. Then you need beta times 2 beta, so that's going to be a 2 beta squared. So this is what we get. Then here we try to just gather the like terms. This is going to be your 3 alpha plus beta. Then down you simply get, I'll combine these two. So this will be alpha squared plus beta squared. Then plus, this is 4 alpha plus that, that's going to be 5 alpha beta. Then this we can make replacements because we know what alpha plus beta is. So alpha plus beta, we said it's what? It's a 4. It's a 4. Then we have 3. Alpha squared plus beta squared is always going to be a 20. We already got it, so we're going to have a 3 and a 4 there. Then we have a 2. This is a 20 plus 5 negative 2 there. Yeah, this will give us a 12. We have a 40 minus a 10, so this is going to be 12 over 30, and 3 can go there, which is 4 times, is it? And 3 can go there, which is simply 10, so we can just say 2 there is 2, 2 there is 5, so you can get this. Yeah, so this is what you get for your number E. The same thing will be done for the last one. So you can pause the video and attempt to do the last one before you see how we're going to do it. So this is 1 over alpha plus 1 1 over alpha plus 1, then plus 1 over your beta plus 1. This is just alpha plus 1, then this is beta plus 1. This will be beta plus 1 plus alpha plus 1. This will just end up giving us alpha plus beta, then plus 2. Everything is simply going to be that, alpha, then plus beta. So you have alpha times beta, then you have alpha, then you have beta, then you have a 1. So this will just give us a 4 plus 2, a negative 2 plus 4, then plus 1. This will be a 6. Then this here will be 5 minus 2, which is just going to be a 3. So this will just give us a 2. So this is what you should be getting, because alpha plus beta was just a 4, and then alpha times beta was negative 2. So because of these, now we're getting these substitutions here. So that answers your question number 2. So this is your number 2 here. Question number 2 is done. We can now go to number 3. So number 3 is still on roots, except here they're saying we need to find the quadratic equation with integer coefficients which has these roots here. So here the formula is going to be the same. So I'll just do 2 questions. I'll do this one here and I'll do this one there. So whenever you are given 2 roots, remember, if you have alpha plus beta, this always gives you what? This always gives you negative b over a, right? Then if you have alpha times beta, this always gives you c over a. Now, if you know the roots and you want to form back the quadratic equation, you can add those 2 roots here and then put an x outside, then multiply those roots here, then equate the thing to what? To 0. In short, we're just saying any quadratic is equal to minus the sum of those 2 roots, then plus the product of those same roots. So we can have this, yeah, some people just say the sum x, then plus the product this side. It's the same thing. So if you know the roots, for example, I tell you to say, you know to say this quadratic. If you solve this quadratic, 6x plus 8, when you solve this, the answers you get will simply be what? 2 and what? 2 and 4. So now, imagine we didn't see this. Imagine we don't know this. I gave you to say there's a quadratic that has answers 2 and 4. Can you find it? I'll say x squared minus the sum, meaning I add 2 and 4. So I'll say 2 plus 4. Put an x, then say 2 times 4 this side. This is equal to what? 0. So now the quadratic has now been formulated. You are seeing that you are getting the same thing that was here, right? So this is the same thing that they're telling us. If you know the answers of a quadratic, so either this can be called your alpha, this can be called your beta. It doesn't matter however you call them, whether you switch. Even if this is your beta, this is your alpha, the answer is always going to be the same. So that's what they're telling us here to say. Imagine these are the roots. Can you formulate back the quadratic equation that gave us these roots? That's what they're simply asking. So we'll start with the first one. The first one is simply your 1 minus 4i. So meaning this gave us, it gave them complex roots, right? So how do we formulate a quadratic which had complex roots? So this is question number 3. I'll just do B. So the roots are 1 minus 4i, and you also have 1 plus 4i. So we'll just say x squared minus, you sum them up, 1 minus 4i plus 1 plus 4i, x, then plus. This side you multiply them. 1 plus 4i is equal to 0. So this will just be a 2x, then plus. This will be 1 plus 4i minus 4i. Then this is just going to be a plus 16, because I squared is going to give us a negative 1, right? So to create this, this is x squared, then plus your minus your 2x. So this is minus 2x. Then this side, if you add all the real things, you're simply going to get, so this goes away, you just get a 17 is equal to 0. So this is the quadratic whose roots are 1 minus 4i and 1 plus 4i. So this is basically what we do for each question here. So I also do C. The rest you can do, and feel free to do your confirmations if you're uncertain with what you are getting. But the formula is correct, so whatever you get will be the right thing. Yeah, so the number number 3c, if you are to do 3c, so this is your alpha is given, so alpha is equal to 4 plus 2 root 3. So 4 plus 2 root 3, then you have your beta should be 4 minus 2 root 3, just for confirmation's sake. So this is correct. So now, if we're interested in getting the quadratic equation which had these roots, we'll still use the same formula. We're saying x squared minus the sum, so we add them, 4 plus 2 root 3 plus 4 minus 2 root 3 x. Then plus, we multiply them this side, 4 plus 2 root 3, and then you have 4 minus 2 root 3. So this will just be x squared. This will be 8x. Then you have plus, this is 16. That's just going to give us your 4, then 2. So if you do it carefully, you'll find the same thing that I'm getting here. That's going to give us a 24 is equal to 0. So this right here is the quadratic. So I did multiply, in case you're wondering how did this whole thing become 16 plus 4, because 4 times 4 is 16, right? 4 times this is going to be negative 8, then root 3. Then this times 4 is still going to be 8, then root 3. Then the last thing is this times that is going to be minus 2 times 2 is 4. Then root 3 times root 3 is simply a 3, right? So, okay, this has to be a 3 this side. Pardon me, this has to be a 3. Let's make the correction here. This has to be a 3. So if this is a 3, meaning this is going to be 16 plus 12, that gives us a 28. Because this is going to be 16, this gives us a 0. Then you have, oh, it's actually a 12 this side. Pardon me, it's a 12 with a negative. Yeah, so it's going to be 6 minus that. That's simply going to be a 4. So this is giving us a 4. So this is what you get. Because this part here is negative. So this answers your question number 3. So like I said, the formula is the same. You can try out to get the quadratic equations for these others as well. Then you can confirm with me on WhatsApp. Yeah, so look at your number 4. So number 4, they are saying number 4 is similar to number 2. So even here, I'll just do the ones that I perceive to be a bit challenging. Then the rest, I'll just leave them up to you. So we're saying here the roots of this quadratic is simply alpha and beta. Now we want to find a quadratic equation whose integer coefficients are as the following. So this is basically what we have. So please pay attention here. So here they've given us that there is this quadratic whose roots are alpha plus beta. We don't even have to get them or to know them. We just know to say it has 2 answers. Now we know the following. So I want you to take note of the following. We know to say if we were to add this alpha plus beta, the answer will be negative b over a. And if we were to multiply them, we'll simply get your c over a. And also alpha squared plus beta squared is always going to be your alpha plus beta, then minus your 2 alpha beta. And also alpha cubed plus beta cubed is just going to be the same thing as alpha plus beta, then cubed minus 3 alpha beta. Then you have alpha plus beta. Now there are so many formulas, but these are the basic general ones. So now they want us to create another quadratic equation whose roots are as follows. The first one, they're saying whose roots are this one here. So this is a whole different quadratic equation that we want to create. So the best way that we go about it is by getting the sum. The sum is simply alpha squared plus your beta, and plus the other one is what? Is alpha plus your beta squared, right? Because that's what they've given us. This is the first root. This is the first root, this one here, and then this is our second root. So the sum, we're just adding them, right? That's what we're doing here. So if we add them, this is what you'd get. So if we're adding them, this will be alpha squared, then plus beta squared, then plus alpha beta. So we know what the formula for this is, and we know what the formula for alpha plus beta is. There's a plus in between. Yeah. So that now we'll come here where there's alpha squared plus beta squared. I'll replace this. So I'll replace alpha plus beta squared minus 2 alpha beta. Then there is an alpha plus beta. Now we know what this is. According to this question, our b is -1, right? So we're putting a -1 there, then over 2. So it's just going to be a half. Then our c is simply that. So this is going to give us a 3. Now we can do our substitutions. Where there's alpha plus beta, we'll put a half. Then square it, minus 2. This is simply a 3. Then plus, this is a half this side. So this is going to give us 1/4 minus a 6, then plus 1/2. This is going to be, you can say that the common denominator here is 4 throughout. So I'm trying to add this. So there's a 4. This is going to be 1, 24. Then this is what? A 2. This is going to be a -22, a -21/4. So this is the first thing that we can get. That's a sum. Then the product is alpha squared plus beta multiplying alpha plus beta squared. So this will be alpha cubed, and you're going to get alpha squared and beta squared. Then plus you get alpha beta. Then lastly you get beta cubed. This will be alpha cubed plus beta cubed plus alpha beta squared, and you have alpha beta this side. This will just be alpha plus beta cubed minus 3 alpha beta, alpha plus beta. We know this here is what has been replaced by that. Then we're having plus an alpha beta squared, then plus an alpha beta. Now we can do the replacements. So where there is alpha plus beta, we'll put our half. This is 3. Then this is going to be a 3. This is a half. Then this is going to be a 3 squared. Then this is going to be a 3. This will give us 1/8. This is going to be a 9/2. This is a 9. Then this is a 3. So this gives us a 1/8 minus 9/2, 9, 10. That gives us a 12/1. So the common denominator here is going to be 8. Then this is going to be 8 into 8, that's 1. This into that is simply a 4. 4 by 9 will simply give us a 36. Then 1 into that, 8 is simply going to be 8. We take it there. This is going to give us a 96. So now we can do the substitutions and subtractions. It's going to give us a 61. So this is a 61/8. So now that we know what the product and the sum is, so the quadratic is simply going to be x minus the sum. The sum gave us, remember the sum gave us -21/4 x. Then the product is giving us a 61/8 x squared plus 21/4x, then plus 61/8. Then here we can simply multiply with an 8 throughout. So an 8 is simply going to give us 8 squared plus this is going to be a 42x. It's going to be a 61 is equal to 0. So this right here is a quadratic whose roots are alpha squared plus beta and alpha plus beta squared. So this is how we do it. We first of all find the sum and the product of the given roots. So this is what we did here. So the same applies to, I'll do the last one as well and leave the rest to you. Yeah, so the format is the same. So this, or maybe this one that looks a bit complicated because of the 3's. So we're just saying add them first. So you say 1/alpha cubed plus 1/beta cubed. You add them. This will give you the sum. Then the other one, the product, you multiply these same things here. 1/alpha 3 multiplying 1/beta 3. So now when you get the sum and the product, then you replace in your formula, because the formula says it's always minus the sum x and then plus the p this. So we're trying to make this. Yeah, so this is what you do for each and every question here. So I'll do the last one is the one that looks a bit interesting. Alpha plus beta. So f, this is your number 4f alpha. So we're trying to get the sum, alpha plus beta over alpha, and plus alpha plus beta over beta. So alpha plus beta over beta. So the sum so this is going to give us alpha beta plus beta squared, and you're going to get alpha squared plus alpha beta. So this will be 2 alpha beta plus alpha squared plus beta squared. Then you have alpha beta. Now we already know what alpha times beta is, simply 3. Then this alpha squared plus beta squared, we're from working it out here. So alpha squared plus beta squared, did we work it out? Alpha squared plus beta squared, it's simply this whole thing here. So it's just a quarter minus 6. So this is 1 over 4, then minus 6. Then down, we're just simply having your alpha times beta, which is supposed to be a 3. This is going to give us a 6 plus 1 over 4. That, then you have a 3. This will just give us 1 over 4 over 3. This will end up being 1 over 12. So this is the answer to the last question for the sum. So we've gotten the sum, right? This is the sum. Then we need to get the product. So this was the sum, then the product alpha plus beta over alpha, then multiplying alpha plus beta over beta. So this will be pretty straightforward, because we can just leave the top part the way it is like this, then the down part will be like that. This is simply if you are using the same things, so your alpha plus beta is what? Alpha plus beta according to what we got. So alpha plus beta is half. So this is just half times half over 3. This will be 1 over 4. Then over 3, this will give us 1 over 12 again. So you notice that this will be the sum, which is just 1 over 12. And the product, which is 1 over 12. So this is 1 over 12 is equal to 0. We can multiply throughout by 12. Then this becomes 12x squared, then minus x, then plus 1 is equal to 0. This is what you get. So it's the same thing that you do for everything. We're just saying always get the sum. Then once you get the sum and the product, you can always use this formula here too to do your replacements. Yeah, so that's basically what we are having. So you can try the rest and do your confirmations with me on WhatsApp. Then the next one, number 5. So this is just a repetition about rules, except here they want us to find the values or value of k. So look at the cases that have been given. So case 1, they are saying the roots. They want us to get the roots of this. If the roots of this expression differ by 2, what will be the value of k? So meaning if one is alpha, the other one will be alpha plus 2. It's either bigger by 2 or less by 2, right? And you know to say the sum. So I'll do the first one. So question 5a. So 5a, they're saying these expressions differ by 2. the answers. The roots of this differ by 2. So this is 3x squared minus 12x plus k. So we're saying one is alpha, the other one is alpha plus 2. So if I add alpha plus 2, I need to get the sum. Remember, the sum of roots should give you what? Negative b over what? Over a, right? So my first root is alpha, the other one is alpha plus 2, because their difference is 2 when you subtract them. So now we're just saying this is going to be 2 alpha plus 2 is equal to negative. Your b is negative 12. Your a is simply what? A 3, right? So 2 alpha plus this is equal to, that's going to give us a 4. So 2 alpha is equal to that. So 2, here we're getting what? We're getting, okay, so alpha is giving us a 1, right? So we know what alpha is. Then you also know to say alpha times alpha plus 2 should give us c. So c now is where the k comes in, c over a. That's what you are getting. Now we already know what alpha is. Alpha is what? Alpha is 1. So you can put a 1 there, put a 1. So we have 1 plus 2. Then is equal to k over 2. So this is just going to be a 3. So k is equal to 6. Because this is a 3 is equal to k over 2. So here k only has one value, which is equal to a 6. So for the first one, here we're saying k is equal to 6. It's only one value. Then for the second one, they're telling us that the roots are equal and opposite. So meaning equal and opposite means one is negative alpha, one is just positive alpha, right? Yeah, so if you multiply these two, what do you get? If we were to multiply these two, you'd get negative alpha squared. This should have been, the product is what? C over a, right? C is equal to negative 8 over, this is, our c is that, our a is that. So meaning your alpha squared is equal to 8 over 7. So we know to say this is what you're getting for your alpha. Then to add the two roots, we know to say negative what? Negative alpha plus alpha. This will give us 0, right? Is negative b, which is this guy, over a. So here you will notice that if you try to solve this, this is a 0 here. So 0 is equal to negative k squared plus 4 over 7. Cross multiply, you get negative k squared plus 4 is equal to 0, meaning negative k squared is equal to negative 4, meaning k squared is equal to 4 when you square root, meaning k can either be plus or minus 2. So no wonder they were giving us a two-way case to say it can either be value or values. Like here we just found it to be 1, right? But here they can either be 2. So k can either be plus or minus what? 2. So that's what we are getting. So we're just basically using your idea of roots to say if you know what is happening between the two roots, you can always find whatsoever is missing in the quadratic equation that has been given. So here we're looking for k when we know the nature of the roots, because they say the roots are supposed to be equal but opposite, meaning they are of equal size but opposite signs. So their sum is supposed to be 0, and the sum is always equal to negative what? Negative b over a. So that's how we used this to get this expression there. Then the number c, so 5c, they are saying this thing has two roots whose sum is equal to 6. So we don't know what alpha is and also don't know what beta is, but whenever we add them we should get a what? A 6. And we know summation is that alpha plus beta is equal to what? Is equal to negative b over a. So we know the sum is 6 is equal to, your b is what? Your b is k, so negative k, over your a is what? Your a is 3. So you'll notice that your k here will be equal to, when you cross multiply, k will be equal to negative 18, just one value. So k is equal to negative 18 here. Then for the last one, they're saying this has two distinct real roots. When something has two distinct real roots, it simply means that the discriminant is greater than 0. That's what they're basically saying. So the question 5D, so you need to know, remember the nature of the solution. So here meaning one real root. That's what you expect. Then if the discriminant for AC is greater than 0, meaning you have two real distinct roots. Then if the discriminant for s is less than 0, meaning we have no real roots. They're all imaginary roots. So this is the case we're given is the second one, where we're saying they are telling us that this has two real distinct roots. Yeah, so we'll use the second formula for the discriminant. According to your question here, your a is 2, your b is k plus negative. So the formula is supposed to be b, so b is negative k plus 2 squared, then minus 4 AC. This will be greater than 0. So this now can be written as k plus 2 squared minus 4. There's a 2k plus 1. And then it's k plus 1 greater than 0. This will be k squared plus 4k, then plus 4, minus 8k, then minus 8. We equate it first to 0. So this is going to be k squared is negative 4k, then minus 4 is equal to that. When you solve this, so when we solve this quadratic, you get we'll get to have our k is equal to, you have your 4 plus or minus, you have your 16 minus 4 AC. Okay, so here we're getting a C, so this is going to be 2, this is going to be 4, 16. Because supposed to give us a 16, 16 plus 16, which is a 32, which is the same as this. So this is the same as 4 plus or minus. You're having a 4 root 2 over 2. So this is just going to be a 2 plus or minus 2 root 2. And here we can test. We have a 2 minus 2 root 2. Then we have a 2 plus a 2 root 2. So if you test here using, let's say, 2, you test this side using something like a negative 10. Use a 10 this side. If you put in the expression, we want this to always be greater than, 0. So now if I put 10 into this, negative 10, that is going to be 100. Then that's a plus 40 minus 4, so this will be positive. This is okay. If I put a 2 there, it will be negative. We don't want this. If I put a 10 there, that's going to be positive. So it will be 100 minus 40 is 2 more, it's positive. So meaning the answer, k, must belong in from negative infinity up to 2 minus 2 root that. Then this is going to be open, because they said greater than 0, right? Because if you put this expression in the function, you get a 0. So the solution, the boundary are not part of the set. Then this is union 2 plus 2 root 2 to positive infinity. So this is simply your solution set for all the k values that will make this to have two real distinct roots. So this is what you get as the range of values for k. So this has to do with the roots. So we're just saying the discriminant expression that we use whenever you have two real roots is simply this expression. Now it becomes an inequality when you replace. So that's what we're basically doing here. Yeah, so if you are confused with this, there's a different separate video where we just talk about the discriminant test and how it's done or how it helps us. Yeah, so here it's going to be a range. So here k must belong. Remember they said values, right? So k must come from negative infinity to 2 minus 2 root 2. Then union from 2 plus 2 root 2 up to positive infinity. That will be the range of values here. Then just to spice things up, you can try to attempt E and F. So I'll give you the expressions to use. The formula to use here is whenever you have complex roots, you know to say here the discriminant for AC must be less than what? 0, right? Then has whose root product is this? So they're simply saying has roots whose product, so meaning your alpha and beta here, they should give us half. So alpha and beta is simply what? Your C over what? Your C over A. So you know to say your C is K plus what? 4, right? Then your A is simply K squared. This should give us a half. That's what they're saying. That's a product, right? Product alpha times beta is always C over A. So your C over your A should give us half. Then here you are seeing that this will turn into a quadratic where you get K squared. This will help you to get the values of K, because this is now going to be like this. When you try to solve this now, you get the possible values of what? Of K. So please do attempt this for me to not spoon feed you. Attempt this, then do a confirmation to see if you are following with the techniques that we're using to solve question number 5. Okay, so now we go to question number 6. This is under polynomials, and they're simply asking us to verify, or rather check the whole remainder theorem by getting the quotient and the remainder of the given polynomials with a certain divisor that has been indicated. So like the first one will be straightforward. So now we're simply dividing this polynomial with a linear divisor, right? So whenever they give you a linear divisor, you can do this in 2 ways. You can either use synthetic division or you can use long division. So by linear factor, I mean the guy we are dividing with the highest power of x there is 1. So you can simply say you solve this part. So x plus 3 is going to be 0. So x is equal to -3. So we're simply going to write your -3 here. Then we can say this is, get the coefficient. The coefficient of x to the power 3 there is 1. The coefficient here is -3. The coefficient there is simply a 2. The constant there is 7. Then bring the 1 down. So this is a 1 there. Then multiply -3 times 1. That's going to give us -3. Add this. You get a -6. Multiply that. You get what? You get 18. Then you add this. You simply get a 20. You multiply again by that. You're simply going to get a -60. Then you add this side, you're going to get a -53. So the last digit that you get here is your remainder. Then this here is your quotient. So the remainder, r of x, is equal to -53, and the quotient is the numbers that you've gotten here are to a 1 degree less. So this is simply, it was like this, then you have your constant there, right? So the polynomials to the power 3, the quotient will be to the power 2. So I'll just write my 1 and put a 2, then -6 and put an x, meaning the constant now follows. This is what you get. So this is your remainder, and then this is your what? Your quotient. Now this is only possible if the divisor is a linear expression. But what if it's not a linear? What if we wanted to use long division? So if you want to use a long division, you still do the same thing, x plus 3. Then here you're simply getting your polynomial. This is what you get. You have your -3x squared, and plus 2x plus 7. So this is what we get, making sure that the values of x on the polynomial are put in a descending order. So that's what we always have to make sure. If there's no place value of something, we put a 0. For example, if the polynomial was this, let's say 6x, then plus, let's say 7, you won't write it like this. Rather, you write it as x3, then plus 0x squared, then plus 6x, then plus 7. We need a place value for x to the power 2. That's what we mean. Yeah, for you to put your expression under this long division symbol here. So this is what you have. Then we'll start now by dividing with the first thing. So we always divide with x That's what we always do. Only x is used for division. So we'll say x into x cubed. It is simply going to give us x to the power 2. Then now we multiply x times this. So when multiplying, we use everything now. X times x squared, that is going to be x to the power 3. Then 3 times x squared is simply going to be your 3x squared. Then this is going to be minus, this is going to give us a minus 6x squared. That's what you get. Then you bring down this positive 2x. Then you divide this guy using the first thing here. So x into negative 6x squared, it will just be negative 6x. Then again you multiply with everything. So x times negative 6x to be negative 6x squared. Then 3 times this, that's going to be negative 18x. So here, again, you find the difference. Always, we find the difference. This is going to give us a 20x. Then you bring down the 7. So the 7 comes down. This is now going to be that. So x into 20x, that's simply going to give us a 20. Then we now multiply x times 20. That's going to give us a 20x. Then 3 times 20, that's going to give us a 60. Then here we subtract. So this goes 7 minus that is negative 53. What you've gotten here is the remainder, that's your Rx. And the thing that you get here on top is what we call our quotient. So this is basically what we do regardless of the divisor that we're dealing with. So long division is preferred because it can handle anything. Synthetic division, on the other hand, this first method here, this is synthetic division. It only works if the divisor is a linear expression, like the way we had x plus 3. Yeah, so long division will be advisable, and I'll just quickly solve the last question. Then you can attempt the others here for verification. You can always inbox and ask. So let me just do this last one, which looks to be very big because it has a quadratic equation as the divisor. Then the polynomial here is raised to the power 4. Okay, so answering your last question on number 6. So like I was saying, you look at the question here, the x values are 8x to the power 4. So you notice that this is descending properly, except here there's something missing. There should have been a value here which was supposed to have x to the power 2, right? But they skipped it to something that has x to the power 1. So that's the place value that I was mentioning, to say you need to represent all the place values. No wonder here I'm going to put this part here, which is 0x squared. We need to see the values of x descending until we reach our constant whenever you're trying to do long division. Then we're always only going to be dividing with the first thing. This is the only thing we'll be using to divide. So x squared into 8x to the power 4. We're just saying x 8 to the power 4 divided by x squared. So this is going to be 8. 2x's here will cancel with 2x's there. So you're simply going to get x squared, 8x squared. So it's always advisable to write that answer on top of the place value that has that degree of x. So this is what you get. And when it comes to multiplying, we said we multiply with everything here. So it's going to be x times that, that's going to be 8x to the power 4. This times that, this is going to be negative 8x to the power 3. Then this times that is going to be 8x to the power 2. Now we find the difference here. So minus, this will go, then this will give us negative 2x cubed. Then this will be negative 8 squared. Because there are only 2 terms here, we need 3 terms at each stage. So we bring the 7x down. That's what we do. Then we divide again. X into negative 2x, that's going to be negative 2x. Then now we multiply. So this is going to be negative 2x3 plus this is going to be 2x squared. Then minus 2x. Then here again we find the difference. So the difference here will simply be negative 10x squared. then this is going to be a 9x. Then we bring down the 8 here, so this is going to be that. Then if we divide x squared into negative 10, this is going to be just a negative 10. Multiplying everything by negative 10, it's going to be 10x. Then negative x times negative 10, that's going to be a positive 10x. Then 1 times negative 10, that's going to be a negative 10. So we can now find the difference here. This is going to be negative x, then this is going to be plus 18. We cannot divide x squared into x because this is small, right? So already here you are seeing that the remainder is equal to negative x plus 18. Then the quotient is the guy on top, so the quotient, this here is your quotient. This whole thing here is simply your quotient. So that's how we go about whenever we're dealing with long division questions. Yeah, and whenever the remainder is 0, we consider that to be a factor. Yeah, so if the remainder is 0, meaning the divisor is a factor of that polynomial that you're dealing with. Yeah, so look at question number 7. So here they're saying factorize each polynomial completely. So as well, here they are all raised to the power 3. So I'll just pick one, and then the rest you'll be able to do it in a similar way. So I'll choose the first one. So whenever we're given a polynomial like this one, we always look for factors that can help us to reduce this until we factorize it completely like they are asking. So here we're not solving, they just want us to factorize it completely. The only time we'll be able to solve is on question number 8. Yeah, so I'll answer these two questions at the same time. So here I'll just add up something to say and solve. Right? Yeah, so here I'll just say and solve. So how we're going to do this question and then solve it is how you do this question and finish it off. Yeah, so it's one and the same thing. Yeah, so here we're saying, look at the last number that you've been given. We're given a 7 here, the constant. You always look at the constant. So the constant has factors plus or minus 1 and plus or minus 7. So now when x is equal to 1, you check what is f of 1. If we put 1 in the whole function, this is going to be plus 6, then here you have a 1, then this is going to be minus 7, so give us 2, plus 15, plus 6, then minus 7. You are seeing this is not giving us a 0, right? We don't even have to go any further. Then f of negative 1, if you check, it will be negative 2 plus 15 minus this minus that. This here is going to give us negative 6 and 7, that's going to give us minus 13, then minus 2, that is negative 15, and this 15, together we get a 0, right? So already we have established the fact that x is equal to negative 1 gives us 0, meaning that x plus 1 is a factor. We take the negative 1 on the other side, so we are creating this. That's why we're saying this is a factor. So you always have to find the first factor. It will help you to reduce the whole expression. So now that we have the first factor, we can use synthetic division to reduce it, because synthetic is better and it works whenever you have a linear factor. So the linear factor, we're going to use synthetic division to reduce this polynomial so that we get a quotient. We already know that negative 1 is a factor, so the remainder is going to be 0. Okay, so if we're using synthetic division, we put the constants. So the constants are 2, 15, 6, and negative 7. And we write the first number, which is a coefficient. These are arranged in descending order of the powers of x. So negative 1 times 2, that's going to give us a negative 2. We add this, we're simply going to get a 13. Then we have negative 13 when you multiply negative 1 by 13, right? Yeah, so when you multiply by this, you put the number there, you add, then again we multiply by negative 1. Then here when we add, we should get a negative 7. Then this will simply give us a 7. Yeah, so when we bring the 7 there, you notice you are getting a 0, satisfying what we initially said, that x plus 1 is a factor, because at x is equal to -1, the whole polynomial becomes 0, right? Yeah, so here we write the factor that we initially had, which is x plus 1, and the quotient that we found, which is 2x to 1 degree less, which is just going to be 2x, then plus 13, x then minus 7. So remember, we are not solving first, we're trying to factorize completely. And when you are here, this is a quadratic, this side. So you have a quadratic that can be reduced further. So you can write the quadratic somewhere here, 2x squared then plus 13, x then minus 7. Remember, you learned product sum factor method. So the product is -14, which is a times c. Then the sum is simply your b, which is in this case 13. So now if we're looking for possible factors, we'll simply use 14 and -1. So that this is now going to be x plus 1. This is going to be 2x squared minus x plus a 14x minus 7. Then this is going to be x plus 1. This will be x, then you have 2x minus 1, then plus 7, then you have 2x minus 1. So this will now become x plus 1. You're having x plus 7, and you have 2x minus 1. So when they say factorize completely, you leave it here, right? You leave it here, where you have these three factors. But if they go further, like on question 8, where they say solve. So first of all, you factorize this thing completely, like the way we've done. Then when they put equal to 0, meaning you're now solving. So now if you are told to solve this, if they say they solve this, we'll just equate x plus 1 is equal to 0, and also x plus 7 is equal to 0, and also 2x minus 1 is equal to 0. So you get your three answers, meaning the polynomial cuts the x-axis at these three particular points. So this has answered both your questions 7 and 8, because on 7 we're just factorizing. Then on 8 we are equating those factors we have gotten, we equate them to 0, then we solve each one of them. Yeah, so that's what we basically have. Then it also answers a bit of your question number 9, because number 9 now they are telling us that we are solving this with an inequality. So it's like I'll use the same example that I'm from doing this question here. So imagine if I gave you this same expression here, rather let's say. So the previous question that we're from solving, imagine if they gave us in terms of an inequality. So they give you the polynomial, then they say greater than what? Greater than 0. Now we are from solving this. We got the factors, we factorized it. It simply gave us x plus 1. Then it also gave us x plus 7 and also 2x minus 1. Then the inequality will still be there. Then when you solve each of these pieces, we've already gotten -1, we've gotten -1, we've gotten -7, then we've gotten half, right? So if we want to check where this inequality is greater than 0, meaning we use the table or the graphical method, but we'll start with the table method first. This is what you get. So you have the three factors, you put them this side. There's x plus 1, there's x plus 7, there's 2x minus 1. So you pick any number which is less than -7, I'll use -10. Any number in between here, I'll use -2. Any number in between here, I can use a 0. Any number after half, I can use a 2. So if I put -10 in this expression, I'm going to get -9, right? If I put -10 there, I'm getting a negative. If I put -10 there, I'm getting a negative outcome. So the whole answer will be negative. Negative times negative times negative. Then if I put -2, the answer will be negative. Here is going to be a positive. There it's simply going to be a negative. This is giving us a positive outcome. I put a 0, positive, positive, negative. This is negative. I put a 2, that's going to be positive, positive. Then this is going to be positive. Now we want where the graph, or rather these three things are all going to give us a positive outcome. So this region we don't want, we want this region. We don't want, we want this region. So meaning the solution will just be open -7 to -1 open union then from half to positive infinity. The reason why we are opening the boundaries, or why the boundaries, these answers are not part of the set, is because it was strictly greater than. If they said greater than or equal to, would have included them. It would have been -1 like this, then would have put it like this to positive infinity. Yeah, so this is what you'd get. So all I'm saying is question 7, 8, 9 are connected. The only difference is that in the first one, we are just factorizing. Then in the second one, which is number 8, we are solving. So meaning those 3 factors that you get, you equate each one of them to what? To 0. Then you solve for the x values of x. Then for number 9, we are solving it, but then it's an inequality. So we are going to test, right? We test in terms of which region is this whole thing going to be positive. So it can also be illustrated using a diagram, or rather the graph, the one we call. So we have 2 methods that you can solve number 9. We are from using the graphical, the table method, but you could have used the graphical method. The graphical method is where you just try to sketch it. So if we were to sketch this thing, the y-intercept is a -7, so it's somewhere here, and we know we're touching -7, and I mean -1 and -7, and then a half, right? So how else can we move to simply deal with these guys? So we can just move like this. This is how the graph is. The only portions where this graph is above the x-axis, where it's positive, is only here, which is between -7 and 1, and also after -2. That's a reason why this thing is greater than 0 at this region and that region. Then it's less than 0 in this region here down, and also this region here. Yeah, so this is another way of confirming whether what we are doing is correct or wrong. So this is basically what we do. Yeah, so this should also help you to answer question number 9. If you're uncertain, you can try one, then give me feedback, then I'll review your working. But all these questions are connected. The same thing applies to number 10, but for number 10, I'll just redo one of them. So I'll do A. So A, they're simply saying, sketch the graph of each cubic function below. Show clearly the points where the graph crosses or touches the coordinate axis, so the x and the y axis. So that's what they're asking us for. So it's the same thing. We just have to factorize this guy completely. We get the 3x values. If they exist, then where it passes or where it touches the y-axis is always going to be the constant. This is the y-intercept all the time. Yeah, so this is our question. We look at the factors of -12. There's a ±1, ±2, ±3, ±4. There's a ±6 and ±12 itself. So the reason why we're doing this is because we're looking for the first factor where this whole thing becomes a 0. So we're just going to do trial and error method, right? Now I can't even start using 1, because if I start using 1, it will not be 0. So it will be a waste of time for us to check. Yeah, but for confirmation's sake, you can just try 1. 1 fails. -12, you see this is not 0, right? You try -1, this will be that, this will be 8. -12, you see this is not 0, right? I go to 2, I try 2. 2 squared minus, this is 16, then -12. This is going to be 8 plus 4 minus a what? Minus a 28, is it? Also is going to be 8. This is going to be 4. This is not equal to 0, right? I try -2. This is going to be -8. Then plus 4. This is plus 16. Then this is that. This is going to be what? This will be 0, is it? Yeah, this becomes 0. So meaning x is equal to -2 is working, meaning that x plus 2 is a factor. That's the first thing that we can get. And then we use synthetic. Synthetic is always easier and fast. So this is going to be the coefficient. This was just the coefficient, which is 1, 1. So this is -1, 1, -8, -12. So now we can bring the 1 down. This is -2. This is -1. This is going to give us a 2. This is -6. This is a 12. That's a 0. and then we are saying we have x plus 2, and this here is x squared minus x minus that. So we have x plus 2. If we solve this part, the product is -6, the sum is -1, so the factors can be -3 and 2. So we're trying to solve this quadratic here to try to reduce it. And if we do so, this is just going to be x, then you have x minus 3, then you have plus 2, then you have x minus 3 is equal to 0. This will be x plus 2, then you have x plus 2, then you have x minus 3. Okay, so we have a repeating outcome, which is this guy repeating. So we'll just show it like this. When you solve it, you just say this, then you have x minus 3, which becomes x is equal to 3. These are the x-intercepts. So these are x-intercepts. We found this. Then the y-intercept is simply the constant, which is when x is equal to 0, y becomes -12. So now we can plot this. So we can plot -2. We need to touch this guy twice, and we're also having a +3 this side, and we are touching the y-axis at somewhere like a -12. So how do we touch this point twice? So maybe this is going to be like this, coming like that, and it goes up like that. So there's no other way that we can touch this number here, -2, twice, and then also touch the -12, because this would have been impossible for us to do. How else can we touch this guy twice? Because if you come like this, meaning you've just touched it once, right? It will look like it's a parabola, which is incorrect to say. So we cannot draw it like this. Yeah, because it will strictly look like a parabola. Yeah, so we have to show that we are touching -2 twice. We've touched it the first time, then on leaving it again, we touch it to come touch the -12. Yeah, this was nicely illustrated if they are all different numbers. So yeah, like here they're saying we just need to show where we are clearly touching the coordinate axis. That's all. Without mentioning the maximum, minimum, that part will be included after calculus, like showing the maximum and minimum points of a polynomial or a cubic function are going to be called the stationary points, which you don't do at the moment. You do it after you've learned calculus. So for now, you just show the values where we're touching the x and the y coordinate, which is always easier to see if you're dealing with a case like the previous one. You had a -7, -1.5, and the y-intercept, the constant was -7. So the only way to connect these guys is by passing here. You couldn't even have thought to do this. So in case you are thinking, why didn't we draw it like this? So we can't draw it in this type because -7 is not here on top. -7 is here at the bottom. So the y-intercept is going to determine how the graph is going to be, because we have to touch it, and we cannot have thought about this because palibe -7 here. -7 is at the bottom. So yeah, that's an easier way to look at it. So the second last question, number 11, they're saying the cubic function h of x is gives a remainder of 11 when divided by this guy, and a remainder of -21 when divided by x plus 1. Find the values of a and b, and hence factorize h completely. So we want to get the value of a and the value of b. So expect such questions in your test 1. Yeah, this is a test 1 question material. And to begin with, we know what the remainder theorem suggests. The remainder theorem says like this first case. So let me just rewrite it. So h of x, so this is your number 11. So h of x is equal to 6x to the power 3. So here they're telling us that if we solve this guy, which is x is equal to 3, the remainder, when we put x is equal to 3 in the function, we should equate it to what? To 11. So we're going to say you have 6, 3 to the power 3, then minus 23 to the power 3. you have 3a, then plus b there. This should be equated to 11. The second one is when x is equal to -1, it should be equated to -21. So 6, -1 to the power 3 minus 23, then -1 to the power 2, then minus a, then plus b. This is equal to -21. So you have the two equations here. Yeah, so these are, we have equation 1, and then this is going to be equation 2. We can now solve them simultaneously. Before we do that, we have to simplify them though. So we have, the first one is 6. This is supposed to be a 27 if I'm not mistaken. A 23, then this is supposed to be a 9 plus a 3a plus b is equal to 11. The other one is simply a 6 and a -1. Then minus 23, this is a 1, minus a plus a b is equal to -21. Then here we're just going to simplify this. Okay, so if you try to simplify this, you will reach at this stage that I've reached. Then we can just try to gather the numbers on one side. Yeah, so please do confirm with me whether you get the same. So because of time, I'm going to be using a calculator here. Yeah, so this is what I got. Then if you take the 162, so 162 minus your 207, I'm getting a -45. When it goes on the other side, it's going to be a 46. So the first one is 3a plus b is equal to a 46. Again, please verify if these will be the same answers you'll be getting. Then this will give us -29. When it goes on the other side, it will be positive. So we're just saying 29 minus 21. This is going to give us 8. So we're having -a plus b is equal to an 8. So we can solve these guys simultaneously. I can just subtract them because here there's b, here there's b. So meaning this is going to give us a 4a is equal to, if we say 46 minus 8, that's going to give us a 38. So the answer divided by 4. Okay, so this is going to be, divide this by 4, divide this by 4. So I think I've made a mistake somewhere here, but just try to verify. That's going to be a 38 over 4, which can be reduced. So 3 there, that's going, 2 there, that's going to be a 19. Then here, simply going to get that. So I'm getting my a to be this. Hope you have, this is going to be a 9, because so 29 minus this. That's going to be 8, of course. Yeah, that's okay. Then once you get your a, you can now replace it and get your b. So a is simply negative. I'm replacing in the second equation -a, which is -19 over that, then plus b is equal to 8, meaning we're saying b is equal to 8 plus 19 over 2. Yeah, so this, if I say plus, this answer here plus 8 is going to give me, so b is equal to what? This is 35 over 2. That's what I'm getting, which is 17.5. So now the format may be the same, but I'm doubting whether these will be okay, because this has to be, initially it would have been proper if we got whole numbers, because from our substitutions, if we make our a substitution here, your a we are saying is what? Negative 19. It's 19 over 2. Yeah, this is 19 over 2. Then your b we're getting a 35. So b, if you notice, we're getting a 35 over 2. So I doubt you'd have gotten fractions if you do it properly. Yeah, so please do verify. This is supposed to be 3 by 3 by 3, right? So this is going to be what? 9, then 27, then 27 by your 6. Yeah, so the whole thing here that you need to do is to do what I've done and then get your values of a and b. So please verify this. Yeah, because I'm trying to lessen the time of the video, so no wonder I'm not going to redo it, but I hope you get the concept. So you solve this guy. So we solve x minus 3 equated to 0, right? It will give you 3. So x is equal to 3. Then replace the 3, x is equal to 3, replace the 3 in the function and equate everything to what? To 11, right? Then the next one, equate, this is going to give you -1. Put -1 in the function and equate everything to -3. Yeah, so that's what you are supposed to do. Yeah, so here I'm getting 11. So okay, my mistake is here, guys. Yeah, I wrote a 1 instead of 11. This has to be 11. So point of correction here, this will actually verify everything or rectify everything. This is 11 here. So 11 plus what? This is we got what? We got a 45 this side, a -45. So it's going to be 45 plus 11. That's going to give us a 56. So this is a 56. Yes, this will make sense now. This is a 56. So if you get a 56, meaning this is going to be 4a is equal to, we're subtracting by the way, so this is going to give us what? A 48 if I'm not mistaken. When you divide by 4, a, I'm now getting 12. Yeah, so my a is 12. Once you put your 12 there, so -12 plus b is equal to 8, meaning b is equal to 20, right? Yeah, so this is what you're supposed to get. And then once you get this, you can now replace in the expression. So the expression now is going to be 6x3 minus 23x squared. Then this a, we're saying a is what? You're getting your a to be, your a is 12. So this is 12x, then plus 20. Yeah, so this is what we're getting. Then everything else will be okay. So now we just need to factorize this. Once you factorize it completely, like what we did on number 8, then you're done. That's what they want on number 11. It's the same format even for number 12. So number 12, they are simply saying we get them the values of P and Q. So let me do this one for you. So we have x minus 1. This is just going to be x is equal to 1. So they are saying these are factors. So if they are factors, meaning the remainder should be 0. So if I put 1 in the whole thing, it should be equated to 0. So I'm going to say wherever there is x, I put a 1 where there's x. So it's going to be p, 1 to the power 3, will not change anything. So hope you are okay with this. This is just going to be p plus q is equal to -7. This is equation 1. Then the next one, this is simply x is equal to 1 over 2 when you solve this, right? 2x minus 1 is equal to 0. So x is equal to half. When you put half in the whole expression, they're saying it should also be equal to 0. So we're already having p plus q. We already gotten, so let's see number 12. So p plus q is equal to, we've gotten -7. Now we want to replace with half everywhere, wherever there's x, so that we get the other second equation. So if I put half here, this is going to be p over 8, then plus, because it will be half to the power 3, right? Then here to be q over 4, plus 9 over 2 minus 2 is equal to that. I can multiply everything by an 8 to simplify things. This will be p 2q plus 4, 9 minus 16 is equal to 0. So we're just having p plus 2q is equal to, let me solve the other part. The other part is just the 36. So 36 minus 16 is going to give us a 20. Goes on the side is -20. So I'm having a -20. I can cancel here. This is going to be -q is equal to 20 minus that. 20 minus 7, that's going to give us a 13. So q is equal to -13. Once you get your q, you can now get your p. So your p is going to be equal to a 6. So you have your p and your q. You can replace them and you can do anything that they ask further, but they're not asking for anything else. Yeah, so this is a general view of your tutorial sheet 12. Please, if you do have any questions or you need a full video to the learning of the topic that explains the topic instead of just solving questions like this, please feel free to WhatsApp me and to access full videos on other topics as well. Yeah, so this is the WhatsApp number. Thank you so much for watching.